All right, in this video, we're going to talk about 3.3 Objective 1, where we analyze questions involving rules of differentiation conceptually. If the limit definition of the derivative can be used to find f prime of x, then what is the purpose of using other rules to find f prime of x? The other rules are easier to use and may take less time than the definition, so that's C. In this section, it is shown that the rule derivative with respect to x of x to the n is equal to n times x to the n minus 1 is valid for what values of n. So they start off just saying the positive integers for that rule. It's going to end up being any real number, but we just start off in this section just with positive integers. We're going to start off talking about polynomials first. So fill in the blanks. The value of the derivative of a function at a given point is the slope of the line tangent to the function at that point. Since the graph of a constant function f of x equals c is a horizontal line with a slope of 0. Tangent f of x is equal to c, horizontal, slope of 0. At every point, the value of the derivative must be 0 at every point. So that's going to be the constant rule that we'll talk about in just a second. Like so. Assume that the derivatives of f and g exist. How do you find the derivative of the sum of the two functions of f and g? Find the derivative f prime and the derivative g prime and then add them together. So that's called the sum rule. It also works for the difference. How do you find the derivative of a constant multiplied by a function? Remember, the derivative is a big limit. Constants can pass through limits, so you just hold the constant, take the derivative, and multiply the derivative times the constant. So that is c. It is equal to the constant times the derivative of the function. How do you find the fifth derivative of a function? You take the derivative of the function using the limit definition or other rules, and then the derivative of the derivative is the second derivative, and you repeat that process until the fifth derivative is obtained. So that's also C. And then last question for this video, it has several parts. So the derivative of 10x to the fifth is this true or false? The derivative with respect to x of 10x to the fifth is equal to 5 times 10x to the fourth. No, it's not, because 10x to the fifth is a constant. So the constant rule should be applied, which says that the derivative with respect to x of any constant is 0. That's C. The slope of the tangent line, f of x equals 4x plus 1, is never 0. Choose the correct answer below. That's true because the slope of that line is always 4. So that's B. And then the nth derivative of a cubic function always equals 0 for n greater than or equal to 3. No, that's false because the third derivative is not going to be 0. Using the power rule here, we have first derivative is 15x squared. Second derivative is 30x. Third derivative is 30, which is not 0. So you can change it to say x greater than 3 or n greater than 3, because as soon as I hit the fourth derivative here, it's going to be 0. So that would be d, but you could change this to simply say greater than 3, or say greater than or equal to 4 would be great if you did that, and that would be true. So if you have a polynomial, any degree that is one more than any derivative that has that's higher than 1 degree more than the polynomial, uh, or equal to 1 degree higher than the polynomial, should give you a derivative of 0. There, I think I said that conceptually right. I think you can see that from what we did here, that because this is third degree, as soon as I take a fourth degree polynomial, it will be 0. All right, that's it for this video. We'll come back next time and we'll talk about 3.3 Objective 2, where you use graphs and tables to find derivatives. See you for the next video.